This is Euclid Book 10, proposition number 23. And this is the illustration. Okay. And Euclid says, a straight line commensurable with a medial straight line is medial. Let A be a medial line. That is medial. That's A. Okay. And let B be commensurable with A. So that means that there is some number that will measure both B and A. Okay. Now we're going to prove that B is medial. For let a rational straight line CD be set out. So now we draw a CD. Okay. And to CD let the rectangular area CE equal to the square on A be applied. So here's the rectangular area he was talking about. Then what he's going to do is he's going to form a square, and all four sides of that square is going to be the length of A. Okay? So the area inside the square that he made out of A, okay, is the same amount as what you'll find in here. That's what he's saying. And if you make this rectangular area, you're going to have ED as the breadth of this rectangle. You would know it as the width, but he called it breadth. Okay. Therefore, ED is rational and incommensurable in length with CD. So ED is a rational line, but it's incommensurable with CD, and this is by Euclid Book 10, proposition number 22. And let the rectangular area CF, now we're going to make another rectangular area, and this is CF right here, equal to the square on B. Alright, so now we're going to turn B into a square. How are we going to do that? We're going to make a square, and all four sides of that square are going to be the length of B. That's how we're going to do it. And let the rectangular area CF equal to the square on B be applied to CD, producing DF as the breadth. Okay, so if we make a square, and all four sides of that square is equal to the length of B, then the area inside that square is going to be the same as this. And DF here is the breadth of this rectangle. Okay. Since A is commensurable with B, the square on A is also commensurable with the square on B. So, when we made the squares that had the length of A and the squares that had the length of B, the area inside those two squares was commensurable. In other words, there was some area that could divide the area in A and the area in B, as we have talked about so many times. Okay? But EC is equal to the square on A. We already established that the square area in here is the same as what was in here. Okay. And CF is equal to the square on B. So the area in here is equal to the area in here. Okay. Therefore, EC is commensurable with CF. So this area is commensurable with this one. Okay. And as EC is to CF, as this area is to this area, so is ED to DF. So this line is commensurable with this line. There is some number that will measure both this and this. And that is by Euclid Book 6, proposition number 1. Therefore, ED is commensurable in length with DF, and that's by Euclid Book 10, proposition number 11. Okay? But ED is rational and incommensurable in length with CD. Okay? So we already said that this line is rational, but it's also incommensurable in length with this one. Therefore, DF is also rational by Euclid Book 10, definition number 3, and incommensurable with length of CD. That's by Euclid Book 10, proposition number 13. So, this is a rational line, but it's incommensurable with this line right here. Okay? Therefore, CD and DF are both rational lines, but they're commensurable with each other only in square. Okay? In other words, no number will measure this line and this line. However, if we make an area out of this, so we make an area out of this, those two areas can be measured by some other area. We can establish that. Okay. But the straight line, the square on which is equal to the rectangle contained by rational straight lines, commensurable in square only, is medial. And this is by Euclid Book 10, proposition number 21. Therefore, the side of the square equal to the rectangle CD, DF, is medial. Okay. And B is the side of the square equal to the rectangle CDDF. Okay, so what we're saying here is that we've already established that the area inside of this rectangle is equal to the area that you would find if you made a square out of B. So that side of B is medial. Alright, now this thing comes with a porism. From this, it is manifest that an area commensurable with a medial area is medial. Okay? And in the same way as we explained in the case of rationals, which was the lemma following Book 10, proposition number 18, it follows, as regards medials, that a straight line commensurable in length with a medial straight line is called medial. Okay, so what we're saying here, that if you have a straight line, and it happens to be commensurable with a medial line, okay, that means there's some number that measures a straight line and a medial line, then the straight line is also medial. And the straight line is not only commensurable with the medial line, but if you squared the straight line and you squared the medial line, then their areas are commensurable at the same time. Since in general, straight lines commensurable in length are always commensurable in square, which is something we proved a long time ago. But if any straight line be commensurable in square with a medial straight line, okay, so now you have a straight line, and it's commensurable with a medial straight line, but only in square. Okay, so in other words, there's no number that divides a straight line and a medial straight line, but there is some number that will measure both the square of a straight line and the square of a medial line. That's what they're talking about there. Then if it is also commensurable in length with it, the straight lines are called, in this case too, medial and commensurable in length and in square. But if in square only, they are called medial straight lines commensurable in square only. Okay. So, that's the porism. I will tell you more in my next video, so stay tuned.